The nearly revolutionary appearance of the J-36-2 prototype, does it signify that China's sixth-generation fighter program has quietly surmounted its most challenging technical exploration phase? Is it now forging the future of aerial combat into tangible reality with engineering certainty? As we scrutinize each meticulously reworked detail, from the dual-thrust nozzle to the integrated gold-coated flaps, from the DSI intake to the reconfigured landing gear bay, a clear signal emerges through these intricate structures. This fighter is rapidly shedding the experimental character of a concept demonstrator. Every improved bolt, every inch of optimized skin, is preparing for eventual mass production, service entry, and the assumption of actual combat duty. This represents not merely technological iteration, but a strategic sprint from laboratory to battlefield. Behind it lies a nation's profound understanding and resolute pursuit of technological supremacy and tactical surprise in the generational competition for air power. The most significant evolution lies at the core intersection of propulsion and stealth, the exhaust system. The shift from pursuing extreme concealment with an integrated circular nozzle to adopting a more technically mature and controllable dual rectangular vectoring nozzle represents a crucial pragmatic pivot in engineering philosophy. The dual nozzle design is not a simple step backward. It represents the optimal solution after comprehensive evaluation of infrared signature suppression, radar cross-section control, thrust vectoring efficiency, and most critically, system reliability. Its wide rectangular outlets minimize infrared radiation from high-temperature exhaust, and radar reflections from the cavity through meticulously engineered hot-cold airflow mixing layers, and radar wave-absorbing structures. More significantly, it provides indispensable pitch control torque for this aircraft, which has completely eliminated vertical and horizontal stabilizers. During high-speed dogfights or high-angle of attack maneuvers, differential or synchronous deflection of the left and right nozzles, combined with coordinated action from other wing control surfaces, sufficiently compensates for the loss of controllability resulting from the absence of traditional aerodynamic control surfaces. This demonstrates that the J-36 flight control system has evolved to adeptly manage the complex, multivariable control logic of aerodynamic surfaces combined with thrust vectoring. This enables it to maintain formidable post-stall maneuverability while preserving its omnidirectional stealth profile. The power source has thus truly transformed into a shield of stealth and wings of agility. The aircraft's respiratory system, the intake duct, has also undergone meticulous redesign. The distinctive DSI bulge intake duct on the fuselage of Prototype 2 features contours optimized through precise fluid dynamics calculations and electromagnetic simulations. This bulge not only smoothly eliminates low-speed turbulent boundary layer flows on the fuselage surface, ensuring stable, clean airflow to the engines in all flight attitudes, but also, through its seamless curved surface design, completely eliminates the inherent strong radar reflectors of traditional intakes, the boundary layer separator and intake lip gap. This exemplifies a design that fuses aerodynamic efficiency with stealth performance to the utmost degree. Combined with its potential adaptive cycle engine, the intake system can automatically adjust airflow based on flight speed and altitude. It meets the fuel-efficient demands of subsonic cruise, while delivering a relentless supply of air during afterburner-powered supersonic penetration. The reconfigured landing gear layout serves as a silent mission specification. The shift from tandem to side-by-side dual wheels is no coincidence. While tandem landing gear offers superior adaptability to rough runways, its complex retraction mechanism and substantial internal space requirements are an unacceptable luxury for the aircraft's limited belly volume. The switch to a compact side-by-side configuration directly liberates precious space in the core belly area. This freed-up space is likely allocated to two critical payloads, a larger internal weapons bay, and expanded fuselage fuel tanks. The former enables the J-36 to carry larger, longer-range precision strike weapons, such as air-launched hypersonic missiles or ultra-long-range air-to-air missiles, within its internal bays, allowing lethal strikes from beyond enemy defenses. The latter directly translates into extended combat radius and prolonged battlefield endurance, critical performance metrics for strategic-level fighters tasked with deep-sea operations, sustained air superiority missions, or penetration strikes. This modification to the landing gear, the aircraft's foothold, clearly defines the J-36's role, an aerial heavy hammer engineered for deep-sea, high-intensity combat environments. When we shift our focus from local details to examine the aerodynamic integration and system integration of the entire aircraft, we find its design philosophy is rapidly converging toward the sixth-generation aircraft concept of a flying sensor, or airborne server. Its massive diamond-shaped nose is expected to house an unprecedented, ultra-large conformal active phased array radar. The antenna aperture may span the entire nose, and even extend onto the forward fuselage, providing 360-degree radar surveillance with no blind spots. Beneath the airframe skin, a dense network of distributed electro-optical apertures and intelligent skin sensors could form a transparent battlefield perception network, enabling real-time fusion of space-based and airborne intelligence. More significantly, its open avionics architecture and formidable onboard computing power inherently position it as the central node of an air combat network. It can not only command and control accompanying loyal wingman drone swarms to execute forward reconnaissance, decoy, attack, and even attrition missions, but also function as a frontline information hub, distributing acquired intelligence in real time to rearward early warning aircraft, surface vessels, or other fighters. This manned aircraft plus artificial intelligence plus unmanned aircraft swarm combat model will fundamentally transform traditional platform-centric air combat paradigms, evolving combat effectiveness into a dynamically reconfigurable, self-evolving intelligence system. The rapid maturation of the J-36 No. 2 prototype reflects a new R&D and equipment culture within China's aviation industry, high-speed iteration, bold certification, and combat-oriented development. The astonishingly short time frame from its maiden flight to the emergence of the significantly upgraded second prototype is underpinned by comprehensive technological empowerment, digital design, virtual flight testing, and intelligent manufacturing, enabling the design, testing, and refinement cycle to operate at unprecedented speed. This marks China's departure from the imitation catch-up path dependency in cutting-edge aviation equipment, entering a confident phase of original innovation leadership. This capability extends beyond individual platforms to the forward-looking construction of next-generation air combat systems. The simultaneous development of the J-36 alongside potential sea-based variants, unmanned wingmen, new-generation air-to-air weapons, and space-based reconnaissance systems reveals a multidimensional, three-dimensional blueprint for air power evolution. Thus, the unveiling of the J-36 prototype No. 2 carries significance far beyond showcasing a more advanced aircraft. It serves as a technological declaration on the future rules of aerial combat, and a physical extension of a major power's perception of its strategic frontiers and national security boundaries. Each of its taxi-to-takeoff maneuvers compresses adversaries' warning and reaction times. Every stealth-optimized contour redefines the boundaries of penetration. The systemic intelligent warfare philosophy it embodies is reshaping the very nature of warfare. From the test runways along the Bois coast to the imagined battlefields of the deep blue seas, the J-36's evolutionary journey stands as the most compelling testament to China's Air Force undergoing a robust transformation into a strategic air force. This airborne colossus, rapidly being imbued with its operational soul, will ultimately serve not only as the sharp sword guarding the nation's gates, but also as the decisive force shaping regional strategic equilibrium and safeguarding peaceful development. Its shadow falls upon the runway, yet its weight has already landed on the chessboard of history.